Hey guys,
Hello.
Hi.
how you doing?
This week's been tough for me.
What's that?
This week's been a little bit tough for me.
Sorry, I like your cat and mouse or whatever in the background there.
Oh yeah, that's not me. That's previous students from last night. It's very artistic.
Yeah. Oh. Oh. So apparently, when the rumor is that, or not the rumor, apparently this is more than a rumor, but the guy who made the comics Calvin and Hobbes, you guys know what I'm talking about? He went to Bill Watterson. He went to Kenyon, and he graduated actually from Kenyon the same year I graduated. And when he was living in, I think it was, wait, I'm trying to remember. When he was living in the dorms there, over there, his freshman year, he painted a replica of the Sistine Chapel on his roof, on his ceiling. Unfortunately, I painted over it. So anyway, but that's gone now. All right, we got to start. I got a lot to talk about today. I've been looking over your what I've got in so far for your team proposals, and I got a couple people who are looking for teams, and so I'm going to be working with them to help set up a team. And so let me show you. And before I show you this, this doesn't say that I've necessarily approved the team. It's just what I'm working with so far, so you know where it's at, and you're aware with what's going on right now. So in the syllabus, I have added a link actually for Friday, and I think you guys already know we're not having class on Friday because all classes have been canceled on Friday, although I think I'll still have office hours because I think everything else is on. What we were going to do on Friday was the demos of our adventures. So sadly that gets cut, but at least that's not a curricular loss. That would have been fun though. So what I put here is project 3 teams, and eventually all of them will be on here as we get teams. Okay, so far I have these 2 teams. These are people who I'm looking to assemble with 1 or 2 other people in a team. And so if you're looking for somebody, Jimmy and Charlie are still available. If not, I'm going to assign them to a team. But I do have these 2 other teams that I'm looking at. And again, I wanted you to make sure you turn in meeting times, and I want a link. So if for this team, I didn't get a link. I actually want a link that I can have so that I can go into your meetings and talk to you and actually, verify that you are meeting, but also just to come in and help you. So I'll ask, to turn all those things in. Now, of course, it's not due till tonight, so you can do amendments. So I just wanted to mention that. So of course, project 2 is due on Friday night. Then today what we're talking about is Node.js, which I've given you a little bit of an introduction to. And we're also going to talk about RESTful interfaces, REST APIs, and JSON. So that's a lot. So I think what I'm going to do, I've introduced some Node.js, right? We understand that Node.js runs on the server side, but it runs JavaScript. So instead of using C++ or Python or Java or some other language on the server, we actually run Node.js. Now, the beauty of Node.js is you can have a single program running that talks to as many web pages as you want. which means we don't have to have this weird FIFO client server stuff, because you literally have a long running program that is talking to a web program. This makes it a lot easier to do a lot of things, okay? And what I've done is I've written 2 programs in Node.js for you that I want you guys to play around with a little bit. In fact, you have an assignment where what I want you to do is do the Node.js ports. And what I want you to do there is to get Node.js running in your directory. And I've assigned everybody ports. Actually, you don't have to have the Node.js, set up Node.js until November 13th. These are ports that I'm assigning to you that I'll talk about in a moment. Now, the way Node.js works is I'm going to actually stop it. I have it running over here, so I want to stop it. So, if I open up a terminal here, and I don't know if this is still connected to the server, but if not, I'll re-log in. Yes, okay. Oops, change directory to tilde. If we go to where is it at? I got so much stuff in here. If we go to phone, rest. Well, I thought, oh wait, that's right. No, it's phone node, not rest. Phone node rest. Now we're going to find out what rest is, okay? But rest is the interface we use, and so we're bringing together several technologies. But let's look at this first, okay? So what we have here, only thing we really need to look at is phoneserver.js is a program that runs on the server. This is Node modules is a directory that contains all of the modules, just like in Python, and where you can import modules, and just like in C++ where you can include things. In Node, you have a directory where all your included stuff is brought in. Okay, so we don't really need to worry too much about that, but I'm just mentioning that what that is. This is a program that we run locally. Now, the way this program runs is it uses Node as a web server. So we're not using Apache. Everything is running here. Now the thing is because we're not using Apache, we can't run on the same port that Apache's run on, because if we try to do that, we'll have 2 problems. One is it's running on port 80, which is a privileged port, which you're not allowed to use. The second thing is it's already being used. It's like the line is busy. So it turns out that on most systems, there's a total of 65,000 ports, because it's a 16-bit port address. And a port address can be thought of as a phone number on your computer. So when traffic comes into your Ethernet port, what happens is it has to be routed somewhere. How does it know where to go? Well, if you're coming in through SSH, it always goes to port 22, and there's a SSH server running on port 22 that you connect to, and you remember typing in port 22. Now, it turns out that web pages are so commonly on port 80 that when you try to go someplace, it automatically uses 80. However, 80 is not secure. It turns out there's another port, 443, that is secure, and generally what happens when you go to a web page, it redirects you to port 443 that has the secure socket layers running on it, and that's how you do secure web browsing. So that's just sort of to give you an idea of ports. Now we need to have our own port, and so what happens is when I run this program, it connects to a port. In fact, let me show you, let me bring up Adam here for a second, and let's go to this code, because it's prettier to look at it here than other ways. So we go to phone node rest. If I look in my phone server.js, what do we see? Well, we see it's actually using something called Express. This has to do with REST that we're going to talk about in a minute, and it works with AJAX to do communication between the web side and the server side. So we require it. This is like doing a import or an include in Python or C++. And then here we're instantiating it, right? We're making an instance of Express. We're also including something called FS, which we ignore for right now. And we're also including SQL because this is a phone book app and it's going to talk to the same database. Then I have to pick a port. And so I'm using port 9002 because it turns out that there's only 20 ports open through the firewall to this server. And what I've done is I've opened ports 9000 through 9020, and I've assigned each of you your own private port, and I'll show you that in a moment. So you're not going to use 9002. And then what this is doing, it's saying for Express, basically what I'm doing is I'm kind of like starting up a web server. And I'm saying that my public directory, remember we saw that public directory, is where the files are at. So that's almost like this is your own mini web. What do we have in there? Well, notice we have an HTML file, a JavaScript file, a CSS file, and a favicon. Anybody know what a favicon is? I know Andy does. Right? Whenever you're on a web page, do you ever notice how there's these little symbols? Right? And it turns out what that symbol is a favicon, and you can make your own favicons so that your own little thing will appear up there and not just some generic thing. Okay, so that's what the favicon is. Wait, let me go back to my Atom. Okay. So what I have here is I have stuff to do my SQL, and notice I'm not going to look a whole lot at it, but notice I can do queries just like I can do in SQL, but this is all JavaScript, right? So how does this thing work? Well, it works. I'm going to talk about REST, and we'll get back to how it works. But the point is, what happens is this program is running on the server. This program is running on the client. And so when you start up and you go to 902, what happens is it serves up the web page that is in there. And the reason it serves it up is because in the server, notice I say get. If I go to /, in other words, if I go to the root directory, it says send file /public phoneapp.html. Right, so it digs into the public thing and it sends this file. So we're basically running our own web server. And then once that's written, that's when we get into the REST stuff and the Express stuff, and that's how this program, not this program, but this program, the phone app running out on the browser talks to the phone server, which we're looking at right here. So let's try this out. Okay, so now the thing is, I need to go to the terminal, right? And I'm in here. Now, if I go to jimscon.com:9002, nothing, because there's nothing there. But over here, if I do node, that's how I run a node program, phone server.js, and I hit enter, what's happening is that code we were just looking at starts up and it says, hey, I'm listening on port 9000. So I come over here and I try again, and sure enough, it serves up the same web page I've seen before, and I can search for things, right? And I can add a new thing, you know, Bilbo Baggins, and his number is garbage, and he's clearly a member of my family, I guess. So close. So it added a thing, and I can go to find last and search, and bam, there it is, right? Bilbo, I didn't spell it right, so edit works. Bilbo, save, search, and now it's all fixed up. So, how is all this working? Well, and oh, by the way, notice this little J with a purple X around it? I made that, right? That's just a little favicon I made for this application. Because if I were to, look at that favicon, it's actually a little picture that's, I think, 64 by 64 bits. And by the way, I put a link in here. If you want to make your own favicons, there's a favicon generator that you can either search for existing favicons, or you can actually go into an editor and make your own. In fact, you can take a picture of yourself and make a tiny little photo of yourself that will be really grainy. That's a picture of you if you do it right, which clearly you may or may not want to do. All right, so we're learning a lot here today so far, right? I'm covering a lot of ground. So how does all this work? Well, I want to talk about two things real quickly. And the REST API and JSON, okay? Now we've talked a little bit, shoot, I didn't want to do that. REST API and JSON, okay. So what do we want to talk about first? Let's talk about JSON first. What is JSON? Well, JSON is a way of storing and communicating information. It stands for JavaScript Object Notation. And so it's a way of representing a JSON object. It's used to format, store, and transmit data. It's commonly used on the web as a method to describe data being sent between systems. So, for example, that's what we're using. We're not doing comma delimited things. In fact, this is a much better way. I just didn't teach it earlier because I didn't want to hit you with too much. But it turns out that, wait, let me get out of here for a second. It turns out that, watch this, and this is something we're going to learn about in a moment, but I can actually just put the query right in here. I can say jimscon.com 9002/find. This is this REST stuff we're going to talk about. And then I say field is equal to last, search is equal to K. It's going to find all things with K in the last name. And look what I get. I get JSON. Well, what is JSON? Well, JSON is basically a very simple language that fits right in with the way JavaScript represents objects, and it also provides a really nice way of passing attributes and values. So let's look at it. JSON syntax. A JSON is made up of objects, and an object is a list of name-value pairs that are enclosed in brackets. Now, if you happen to be a Python programmer, this is exactly how dictionaries are represented in Python, right? If you happen to be a C++ programmer, you can think of a JSON object kind of like a map, because it is, okay? And so, for example, we can have name goes to HTML, years goes to 5, right? And in fact, over here, that's what we see. Notice we have an object here. First goes to Bill, last goes to Yakis, name goes to blah, 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 type goes to friend, ID goes to 2. ID is not in quotes because it's actually an integer. Then we have another array. Name is equal to Wilbur, Black, phone number, and an ID, right? So that's one thing is an object. Now, the other thing is a list. Turns out it's just like Python. Okay, a list is square brackets with things in it, and you can have anything in a list, including objects, right? So if we look here, that's what this is. Notice we have a square bracket, and then I have a object, then I have a comma, then I have another object, then I have my n square bracket. That's it. Now the only other thing that I think should be obvious to you, if you're any sort of a computer scientist at all at this point, is that these things can be hierarchical, because obviously a list can have objects. We just saw that. An object can have lists. And so these things can be arbitrarily deep. And in other words, you could have an attribute colon and an object, or an attribute and a list as its value. So these things can be quite deep, right? In fact, it turns out that JSON is 100% equivalent to XML, which is something else we've been working with, right? You could do everything in XML. You could take your Zork and do it all in XML instead, in JSON instead of XML. It's the same thing, it's just a different representation. So in JSON, a value, remember you have an attribute, which is always a string, and a value, which can be anything, a string, a number, true, false, null, an object itself, or another array. So values can be nested. Strings are always in double quotes and can contain the usual assortment of escaped characters, like special characters. And numbers are in the usual C++, Java, Python format. And white space can be used anywhere, and it just gets ignored, just like in XML. Now, what's cool is in JavaScript, you can read in a string that's in XML, in JSON, and just convert it right into an object and then access things. It's so much easier. Remember all the parsing we've been doing in the past? We have to split things and look for things. It's so much easier. In fact, I'm going to show you an example in a minute, but first, rather than peer at that slide for very long. So comparison of JSON and XML, they're both human readable, very simple syntax, both hierarchical, they're both language independent. They both can be used by Ajax, and they both supported in the APIs of many programming languages. Now, what's the differences? Well, obviously it looks different. JSON is less verbose. JSON can be directly parsed by JSON's eval method, whereas we have to use something like jQuery to parse XML. JSON includes arrays. The names in JSON must not be JavaScript reserved words, it turns out, or you're going to have a problem. And JSON can't be validated the same way XML is validated. So it turns out that JSON can be used in XML with Ajax, which is kind of funny. We're going to find out why it's funny in a moment. But the point is, I can embed JSON directly in HTML, and then I can use something called HTML HTTP request, and it will be automatically converted into JSON. And the funny thing about JSON, Ajax, which we've been using, AJAX stands for asynchronous JavaScript and XML. Oops, we lost a character there, sorry. I gotta fix that or it'll drive me nuts. So it turns out AJAX is made for XML, but it turns out that everybody increasingly just uses JSON, because here's a JSON object, full name, Sean Decatur, org, Kenyon, and here's the XML version, right? Whoops. Sorry. Actually, I don't like this because let me make it smaller so at least it doesn't look quite as bad. There's not being fair to it, right? It's a lot more wordy and verbose to do XML. So let's see how this all plays out in our phone app. So in our phone app, what I can do is I can do a find, and here I want to do a search. Field is equal to operation. Search is equal to search, a get, and then I call process results. Exactly what we've seen before, but here's where it gets cool. Here's on the receiving side. It turns out that process results just immediately calls build table, just like we've seen before. We pass it the results, and all I have to do is a JSON.parse data, and rows is now a JavaScript object. I mean, a JavaScript object, which means what I can do is when I'm building the table, I can just say, what I do is I say rows is the table, that's what I call it, and I say for each thing in the row, because we know rows is a JSON list, or it was a JSON list, now it's a JavaScript list. So I say for each row in rows, and then row.first, row.last, I can just look things up in native JavaScript because it's an actual JavaScript object. You see how that works? No parsing needed. This did all the hard work here when I said parse. Boom. And now I just have access to the pieces. You guys following this? Yeah. This is so simple. You're like, why didn't we do this before? Good question. Right? So going back to Phone Book Manager and looking at how this works. So, before we do that, let's talk a little bit about REST. REST is the other part of this. We're using something called Express, which uses a technique that's very popular. And if you want, we haven't done it yet because I wanted to keep things simple. But really the way most requests are done these days is something called using REST, which stands for Representational State Transform. And this is how, this goes along with the whole world of something called microservices. And the idea is that you put up a server and it provides services, and it uses a standardized interface called REST, which means that applications can call services and get information back, and you don't have to, it's basically like an object-oriented version of web services, right? This is a standardized interface so that if you know a particular company supports REST, which most do, like for example, Google and Amazon and Twitter and all these companies use REST interfaces. And so you can actually write your own web front end that talks to their services without using their web front end. Or you can make a service aggregator, which say, well, I have this web page and it talks to eBay, and it talks to Twitter, and it talks to the New York Times, right? And it's because they all use REST. Well, what is REST? Well, the whole idea of REST, it's basically a communications protocol. And so a browser, as we already know, sends a GET to a web server and it gets an answer back. And it turns out that the sort of verbs we can use with HTTP are head, get, post, put, delete, trace, options, and connect. And what we're mainly interested in is a get and post. So the idea of REST is it's a style of software architecture for distributed hypermedia systems on the World Wide Web. And it was actually introduced in a doctoral dissertation by this guy, Roy Fieldings, who is one of the principal authors of the HTTP specification. And so it's a collection of network principles which outline how resources are defined and addressed. So the motivation for REST was to capture the characteristics of the web, such as everything is addressable by a URI. Does anybody know what URI stands for? Universal Resource Indicator. So the idea is you make a request and you receive a response and you display the response, right? That's what we do all the time. That's what we've been doing throughout this entire class. It exploits the use of HTTP protocol beyond HTTP post and get using put and delete. Now, it's not actually a standard, but it uses several standards. It's sort of this pseudo standard that uses a lot of other stuff. Okay, so the whole idea of REST is it has this sort of triad. We have verbs such as get and put, and we have nouns which are resources. You know, for example, employees, that's a noun. And presumably this is employee is querying employee 1, 2, 3, 4, 5, right? I want information about this employee. And it works with representation. Okay, so that underneath the hood, there's representations of information. In our case, we're using SQL for this particular application that I'm showing you, the phone one. So the key abstraction of information in a REST is a resource. We reach out to a resource and it does something for us. It either changes the state in the resource or it passes us information back. Right? So here's a RESTful thing. Boeing has, not surprisingly, let's try this. If we go here, I don't know, I didn't test this out before class. We'll see if this works, but since the last time I talked about this, there we go. Oh, apparently they're not, but it does, like I said, it turns out that here, mine works if I say find and I give a field. In fact, it turns out I can just say find and let's see what happens. Nothing. Notice it returned an empty list. But if I say find question mark last, does that work? Nope. It's because I wrote it so that it's always expecting everything ampersand search. If I say nothing there, it brings in the entire database because of my search was wildcarded. Okay. So the point is when we look at this, here, my verb, what is my verb in this thing? I say Jim's gone, what's my verb? My verb is find, right? I can say find and I can search for first. And if I do K, I'm going to get all first names. Kelly and Ken have K's in their first name, right? So I'm just trying to see how much more of this I want to go into. Let's go back to the application and let's look how this works now. So if we go back to Atom, let's go to here. Notice how all of these things work. Actually, most of this stuff is pretty much stuff we've seen before, but what I want to show you is all of my URL is just jimscon.com plus port. That's my URL. Now in all my Ajaxes, let's look at my Ajaxes. In all my Ajaxes, what I do is I say, here I'm saying update, that's a verb, and I'm giving the ID and the values of the things I want to update. Here I'm finding, I do a find, which field I want to find, and what search string I want to search for. Here I'm doing a add record. I have an add record verb. I don't know why I used add record instead of just add. And then all the fields I want to add. Okay. And here I'm doing a delete, and I just say delete is my verb, and I'm using a type delete. Delete is my verb, and then the ID is the ID of the thing I want to delete. In fact, let me prove this here. Here, I search for everything. Let's get rid of Bilbo Baggins, whose ID is equal to 12. All I have to do, I'm not sure this will work because that's a delete. But let's say delete ID is equal to 12. I think this actually won't work, but we'll find out. Now let's do the list. And I'll tell why, but it might work actually. Bilbo Baggins is still in there. The reason it didn't work is because I did a get, and this is expecting a delete. Okay, so all of the other ones are using gets, and so I can do those from a web browser. But there's a way to do a delete, but you can't do a delete from a web browser, just right from the browser like I was doing. Okay, so but all of these other ones, like let's say I want to add a record. Well, here is a record, add first, last, phone, and type. So let's try this. I can say this add rec, question mark. Well, I gotta look at this again. Yeah, question mark first equals Jim and quote last, not quote, last equals quote scon, I'm just going to use lowercase, and type equals family and phone equals blah, blah, blah. Okay, let's copy that just in case I made an error there. Let's try this. All right, what did I do wrong? This is a get add rec. It says that site can't be reached. I wonder if this is still running. Let's see. Ah, I crashed it. When I did the delete, I think I crashed it. Let's try again. Okay, so we try this again. Ah, I'm crashing it. Wow, I don't have a good program if it crashes that easy. What in the world? Somehow I've got into search mode on this page. Let's try this again. You guys see anything weird I'm doing in there? Every time I do that, it crashes it. Values Jim, scon, data truncated from column type. Well, let's do this. Let's actually do a delete and look at the we can actually do a delete and look at the packet and see how my delete is different from this delete. So let's try to delete Bilbo Baggins. Delete record. Okay, so here's the delete. Oh, that's not what I was trying to do. I was trying to do an add. Here's the delete right here. See it? Jim's gone, 9002, delete ID equals 12. We do a search and Bilbo Baggins is gone. Well, I'm crashing this a lot apparently. So I'm gonna after class have to look at this and see why there's a bug in there. But I've tested this a lot and I'm surprised that I now have errors, but apparently delete is crashing it. There it says delete, close. Now I search and it worked. Let's do an add. Just BBB, just to make it easy to find. 2222 and family. Add, close. Now we can look at this add record. Let me see, add rec first equals a, oh, I put quotes in there and I shouldn't have done that. All right, so let's try this again and get rid of the quotes and see if I can actually add something. I don't know what I was thinking about putting these quotes in there. That did not make it happy. So let's try to add this. There we go. Field count 0, affected rows 1, insert ID is 14. So it returns a JSON status package back. And now if I go here and I do a find last and search, there's Jim Scon in there. So the point is I can send these packets from anywhere and I can get it to do things for me. Now let's take a little bit deeper dive into the code, because we've been looking at the web side and we see that what we do is I always send the URL and a verb, right? Add rec. URL and a verb. I gotta find another one. I'm going the wrong way. Delete is delete, right? There's find, right? There's update. So how does that work? Well, let's go back to the server side, because the server side is what's receiving this. Now, it turns out we can ignore the SQL for right now. What happens is in my code, I have a bunch of routines that are basically, remember when I, up here at the top, I said app is equal to express. Express is what talks to Java Ajax on the server side. So I'm creating something and I'm calling it an app. I'm calling it app. I could call it whatever I want. And notice then I can say app is an object and I can call app. And so what happens is app.get and then I give the verb. If I call the app and I have a slash list, this code gets called. If I do a slash find, this code gets called. If I do an update, this code gets called. If I do an add rec, this code gets called. And if I do a delete, this code gets called. You see how cool that is? So it's really easy to on the server side, all I have to do is recognize the verb and then do it. So let's look at slash list, since that's an easy one. Remember, slash list is expecting to get a field, right? Because here I'm a field and then a search string. So, oh, by the way, just slash list with nothing after it selects everything. And we saw that here, right? Here we do a 902, whoops, wrong one. Here we do a 902 font list. I just get everything, okay? So list just selects everything and sends it back. And notice what it does is it sets up a query and it sends that query to JavaScript with a callback. So it's saying, basically what this is saying is call the con up here is my connection to JavaScript with all my host and database stuff in there, just like we've seen before. This says, when they call list, create a thing, and then call the connection to the database, passing it the query, and call me back here. I have an embedded function, because what's here is a function that's going to be called back asynchronously when this is done. So just like in other JavaScript, this is all asynchronous. And this is the beauty of all this, is that this function runs sometime later. If you put code after this, it would not. I don't know why I don't like my indenting here. Let me fix this. Oh wait, yeah. If you put code in here right after here, it would get called before this code, because this code isn't going to get called until the SQL query is done. So we're saying call this function. Now it turns out that by definition, what a query returns is a possible error, the result, and something called fields. Now we don't really care about the fields, but it turns out that error, if an error happens, I throw the error. I could do something else. If I wanted this to be more, and that's probably why my program is crashing, is I need to handle errors more eloquently. I console log the result to print it. And then what this does, what's RES? Well, it turns out that RES, this is a request and a result. When you call apt-get, it actually passes a function that we're supposed to call back when we're done. All of this stuff, and this is a whole different way of thinking. Okay, we can't think about, well, I call something and I get returned. That's not the way JavaScript works in this multi-threaded environment. What happens is when this function gets a match, a hit on this, it calls this function, whoops, and it passes into it the request. The request is what got sent to us. That includes the fields. There's no fields here, so we don't really care. We'll see in the next one, we're doing something with request. This is actually a function that we're gonna call back when we're done. And so I say, this object, this request object, end, and I wanna pass back a JSON version of the result that SQL returned me. And it turns out that there's a parser within JSON called the stringify, and it will take the database results and turn them into a JSON string. It's all like magic, right? So how does find work? Well, find works is just a little bit more complicated, but not bad, right? So we say apt-get, if we see a /find, right? If I do this, search, here we see the thing, it does, no, that's an ad record. I'm looking at the wrong one. Find, here we go. Here we see Jim Scon, find, field equals last, search equals nothing, because I didn't put a search in there, right? So that's what a find looks like. So what happens when we get a find, this gets called request and result. I console log it just for the fun of it. If we look over at this, at the output, we'll see output coming out. And what I do is it turns out the request.query contains the things that they sent to me. So field and search, remember? Field and search, field and search. So request.query field are the fields. So this is just like in C++ and Python, where I do the CGI stuff, right? I'm getting the field, I'm getting the search. If either of those are undefined, I say missing query field. and I return an empty list, result.end. Remember, that's the callback to the result object that'll send the information back to the web page. Otherwise, I get the field that I want to, and I get the search, and I use it, I log it just for fun. Then I say select from phone book, where field is like request.query.search, right? Because this is the thing I want to search for. So I'm saying like last is scan, or first is gem, right? So I'm looking that stuff up. I'm building a select string, and then again, it's just like what we saw before. In fact, I could probably make this code easier because this is the exact same code we saw before. I pass the query to here, I get the results back, I stringify them into JSON and pass those back, which causes them to send them back to the web page. So this is all real easy. This is actually, of all of the versions of phone that I've sent you, this is the simplest, right? And so if you wanted to, for your last project, you could do it this way. You could start from this code, and it would probably be less coding. Now, you would have to learn sort of this JavaScript, REST, JSON stuff, but the overall coding is going to be simpler. All right, so we're done. I didn't get to talk about the chat app, but the chat app doesn't use Express. It doesn't use REST. It uses something else to actually push data directly out. And it's kind of cool. We kind of saw it last time. Maybe I'll talk about it if somebody's interested in doing a game. But if you're not interested in doing a game, then it's probably not worth me talking about. So, hey, have a good rest of the week. Enjoy your Friday off. I look forward to getting your team proposals. And again, I may mix things up a little bit, but I'm going to try to honor what you guys want. And I will see you for sure next Monday.
Thank you.
Did any of you guys stay up all night watching election stuff, or did you guys go to bed?
I went to bed.
Good. I went to bed too. See you later.
Bye.
Professor Scott,
Yes.
I just sent you our meeting link, in the chat.
Oh, good. Oh, I better get it before.
Yeah, can you just copy that to the website?